Welcome back to NPTEL course Food Packaging Technology. So we had been discussing about different aspects of packaging in the last class. We have also discussed about the need and role of packaging, and we also discussed about paper as packaging material and glass as packaging material. So in today's session we are going to discuss about metals as packaging material. Under this, we'll be discussing about tin plate containers, tinning process, and what are the different components of tin plate, then tin-free steel, then aluminum containers, different types of cans and lacquers. Now coming to the metal packages, these are very robust and durable. Because of this, they are used for canning. They are also used to store canned products, dairy products, drinks, non-canned food products. They are used to develop metal closures, metallized films, laminates, and even they are used in non-food products like paints, varnishes, lubricants, and cosmetics and other biological products and medicines. And the reason why we use metals as a packaging material is because it's easy to open, it is recyclable, it can be recycled and reused, and it's convenient to transport and store, and even it can be stored for very long time. It has a very long storage life, and it is impermeable to gas, light, and microorganisms. But then these parameters, it depends upon the kind of material that are being used and what is the shape of the material. Now we have tin plate, which is the older packaging material, and this can be in the form of round, square, or rectangular. The first tin cans were patented by Peter Durand in 1810, and it was based on the experiments of Nicholas Appert, and he developed the process of sterilization, and this was later called as appertization. Today also we follow the same term, sterilization or appertization. So the name was given based on the name of the scientist. And tins, they are light in nature. Even from the consumer point of view, it is easy to handle and they can carry it. It is much lighter, and it reduces carbon dioxide emission during transportation. So this is environmental friendly also. Metal packaging materials, they generally contain aluminum and steel, and these are recyclable and reusable. Once it has been opened, and it can be reused for other purposes also. Need not be for storing food, it can be used for storing other things. Then in this picture you can see different types, a variety of packaging materials are shown here, and all these packaging materials are metal containers, and they can be cylindrical, rectangular. We also have boxes here. Now metal cans, mainly used in the food industry, they are of two types, that is 2-piece can and 3-piece can. So this generally contains one body, that is cylinder part, and it may have one or two lids depending upon the type of can. So if it is a 2-piece can, it will have one lid, and if it is a 3-piece can, then it will have two ends, that is one lid and the other bottom part. And these lids are seamed to the can, and inside this the contents are stored. And generally, because of the sturdy nature of the can doesn't need a secondary packaging. They can be, the number of secondary packages or the tertiary packages can be brought down. Then we also have beverage cans, which are lightweight. Though they are lightweight, they are unbreakable. They can resist the impact during transportation. They are puncture resistant. They can withstand very high temperature and pressure, and they are good barriers to light, gas, and oxygen. And mostly the cans used for packing beverages, they are 2-piece cans. And the metals, they can also be used for developing closures, lids, crown corks. This helps in keeping the contents airtight, and also they ensure neutral taste, and which is very much important in baby foods or infant foods, processed fruits and vegetables, jams, dairy products, and other delicacies like sauces. So the contents from the tin or the container or the lid, it should not leach to the contents inside, and it should not interfere with the flavor of the product. We also have drums and pails. Drums and pails are large containers. These are generally 3-piece steel or stainless steel containers which are aseptically filled. Then we have containers for aerosols. These can be 3-piece or 2-piece. and these are generally used for whipped creams. And then we have trays and foils. They can be rigid, semi-rigid aluminum trays, and these are made from aluminum rolls or aluminum alloys. Generally, the thickness of this aluminum sheet, it will range from 70 to 300 microns. And apart from this, we can also develop tubes using the metals. These metal tubes, these are used to store tomatoes, paste, mayonnaise, and then concentrated milk spread. In food industry, we generally find these things stored in tubes. This is easy to use and easy to take the contents, and these have minimum interaction with oxygen and light. You might be familiar with the toothpaste, which is also a tube container and which is extruded from the metal. Then composition and properties. The packaging materials, they are divided into three different classes, that is aluminum, coated plates. Under this we have tin plate, tin free steel, polymer coated and steels, another class called stainless steel. Then we also have containers of minor elements like nickel, copper and titanium. Now coming to steel based or tin plated steel material. Steel based is also called iron based materials. Components of this will be tin, steel and chromium, which are used to develop the composite material or to form the tin plate. And we can also form electrolytic chromium coated steel. So it is denoted as ECCS. And since it does not contain any tin, it is tin free steel. That is why it is called TFS. So we have the iron and it is base material onto which the chromium is coated directly. There is no tin layer in between. That's why it is called tin free steel. And iron is the bulk chemical or the major base material here. And steel and stainless steel, they are produced from iron and other components. The composition of these components are different in these two things. The steel and stainless steel, they are not one and same. The carbon content and the metal contents differ in each. Then iron ore, coal, lime and ferroalloys are needed to make steel. We also need aluminium, chromium, manganese, silicon, titanium, vanadium. These are other components that are added to improve the properties of the steel. And steel can be made in two ways, by melting the contents in blast furnace, or we can use electric furnace. Generally, the electric furnace is used for recycling or recovered steel. The recycled steel is melted using electric steel. Generally, we go with, if we are going to use natural sources, then we use blast furnace. In this, the iron ore and the coke, it is melted at very high temperature, and the carbon ranges between 0.03 to 2%, because carbon is a contributing factor for the strength. Similarly, phosphorus and nitrogen, it contributes to stiffness of the container or the material. Now there are four different types of steel. We have on the left side, you can see it is L, D, N, Mr, and the properties and their applications, and then composition is also given here. So L, it is highly pure and it is very good resistance, highly resistant to corrosion, and generally these are used for packing acidic foods like pickles and other things. And then we have D type of steel, that is non-aging steel. It is dedicated for severe drawing operations. And N stands for nitrogenized steel for higher rigidity. Such steels are used for developing drums and cannons. And then we have Mr steel. These are most widely used tin plate, and these are used for packing meat and vegetable products. These are not too corrosive. And then tin plate steel, these are also called low metalloid steels, that is L stands for low metalloid. And then Mr type, they have high amounts of carbon, aluminum, phosphorus and copper. Now tin plate steel, this is the main raw material which is used for developing cans and metal boxes. So it is made of mild steel and carbon content is below 0.08%, and it is coated with a layer of tin, and this coating is called tinning or tin plating. This technique is hot tinning technique, and it is generally done by dipping the sheet into the molten tin, and this gives a whitish gray color or dull matte appearance to the tin. This process is like sandwich. This sandwich alloy of steel and tin, it has a good hardness and it has high resistance to corrosion, and this is a non-toxic alloy. Again, tin plating can be done by electrolytic deposition. It is another way of coating the tin, and this generally includes pickling, that is descaling, removing the unwanted parts and then making it smoothen, and then degreasing, washing, alkaline tinning and acidic tinning. Tin-free steel or ECCS, electrolytic chromium oxide coated steel. So this is a tin-free steel. It does not contain tin. Instead, it is coated with chromium, and it is coated in the same way like how the electrolytic coating is given. It is in the same way the chromium is also coated. So it can also be called as chrome iron. It can be written as ECCS. So it contains chromium oxide, which has a thickness of less than 1 micron, and process is similar to electrode tinning. The requirements for ECCS, that is single or double cold reduced electrolytic chromium oxide coated steel, that is ECCS steel, it is given in ISO 11950. It has the specifications are given for both sheets and coils there. So if you look at the figure here, it is a multi-layered structure of tin plate and tin-free steel. In this, you can see that the thickness of base material, it can range between 100 to 350 microns. And over the base material, a tin coating is given, which is not given in the tin-free steel. There's a tin coating or tin alloy is put, over which there's a free tin, which has a thickness of 1.35 microns. And over this, the passivation layer is put. So in case of ECCS or chromium coated or tin-free steel, you will not find the tin here. Instead, the thickness of base steel will be much higher. We'll have a chromium or chromium oxide layer over which the oil layer is given. The passive ion layer, it is a metal layer, and this helps in preventing corrosion. It is generally done by treating the tin surface with nitric or citric acid. So this elongates or prolongs the shelf life of the metal container or the metal sheet. Then we have stainless steel, which is used for food packaging. Stainless steel is also denoted as SS. This is inert and non-corrosive, and it is a reactive chromium which forms a passive coating and which creates a barrier to corrosion, and chromium percentage is around 10.5%. which also enhances the durability of the product, stainless steel. And stainless steels, they are generally heat resistant and they have a hard surface. It is clean, reusable, and it has a good finishing. Generally, 100 grades of stainless steel have been recognized and reported, but they are classified into 5 major groups, and these are precipitation hardening, martensitic, ferritic, duplex, and austenitic. So these are the different groups of stainless steel. Now you will be familiar with 304 stainless steel and 316 or 318 stainless steel. Usually we use 318 or 316 stainless steel in food industry. The parameters or the properties are almost similar to 304 stainless steel, but it also contains 3% of molybdenum. Molybdenum, it reduces chloride-related corrosion and it adds extra strength to the container. Now, 304 stainless steel, these are generally used to develop grills and other kind of fabrications, and it contains manganese, carbon and nickel along with chromium. It has 24% of chromium. Then we have aluminum-based material. Aluminum is the third most abundant element on the surface of Earth. And aluminum is used to develop lighter, thinner, ductile materials, but aluminum, it cannot be welded. And Coors company, they were the first, or they were the pioneers to use the aluminum cans. They started using aluminum cans in 1959, and thereafter it was continuously being used for the production of soda, energy drinks, sparkling waters, and other kind of beverages. And it has become the most sustainable beverage packaging material. It is mainly promoted because of its recyclable property. It can be used in different forms like bins, bottle caps, soft packages for liquids. It can also be used for bulk packaging, capsules, then bottle stops, medication tablets, blister packaging, etc. Usage of aluminum is still promoted because of its light nature, and when we go for light nature, we have to use purest aluminum. Then we can also use magnesium or manganese as an additive, but this will improve the resistance of the packaging material. Aluminum oxide, which is extracted from bauxite, for extraction purpose we need very high energy, and primary aluminum is recycled and purified to liquid metal, and it is filtered using ceramic filter, and it is cast into ingots. Ingots are the molds where the aluminiums are poured and they are stored. From this ingots, these are taken and they are converted to sheets. So any imperfections on the surface of the ingots, they can be removed by polishing, and then these are developed into sheets which can be cooled and used later. So in this picture, you can see different types of ingots. The first one is ingot which is developed in a home. In the commercial way, it is done in a mold like this. So in a commercial scale, the ingots are put in cast like this, and then they are developed into blocks and stored for a later period. And these ingots, they are made into sheets to be developed as containers or other purposes. Now these are the applications of aluminium. And along with this, you can also find the properties and compositions. So aluminiums, they can be converted to foils or flexible tubings, and they are given number of 1050. This is how the flexible tubes and foils are designated. So this is a 1XXX series, and then we have beverage cans. This is a 3-piece can. It has a number of 3104. Then 2-piece 5042. Likewise, we have others like foils for lamination 8079. So it belongs to 8XXX series. And here, if you see the beverage can, it does not contain chromium. It has high amounts of manganese. And whereas the easy open beverages or 2-piece cans, they have all the ingredients. But foils for laminations, they do not contain manganese, magnesium, chromium, or titanium. Now 1XXX series, these are commercially pure aluminium. These are unalloyed, and iron or silicon, the common impurities that are generally seen, and these are used for developing aluminium foils or extruded containers. We also have XXX aluminium cans or aluminium containers which has high amounts of manganese, and then we have 5XXX series which has 4 to 5% of magnesium and 0.5% manganese. These are used to develop rigid containers, especially cans. And then 8X series, these have wider applications and a wider range of composition also. Then can manufacturing, we have 2 types of cans, that is 3-piece can and 2-piece can. In the 3-piece can, there's a cylinder body which is rolled from a sheet of tinned steel which is welded on the sides, and the 2 ends are joined mechanically by crimping. And in the 2-piece box, the cylindrical body is stamped, so it is seamless and it's easy to open. So 2-piece cans are very common now. 3-piece cans, they were earlier used to store or to can the meat products, but now they have been replaced with 2-piece cans. So these are examples. On the above figure, you can see 3-piece cans. They come in different shapes and size. And 2-piece cans, again, they can be rectangular or cylindrical, and they have a lid on the top. The bottom part is part of the body itself. Now let's see how the 3-piece can is manufactured. So it consists of cylindrical body, which is rolled from a piece of flat metal with a longitudinal weld joint. Usually it is done by welding or soldering, and together with 2 can ends which are seamed into each end of the body. And usually these are made from tin plate. Now let's see processes one by one. We have thin metal strips here. These are cut into desired sizes, and then these are lacquered. Coating is given on the surface to prevent corrosion, and then these are dried. Usually the lacquering is given on the internal side, and after drying, these are cut into the size of the containers, and then it is rolled into cylinders, and both the edges are kept together and welded or soldered. And then again lacquering is applied on the sides, because when we are doing rolling or welding, sometimes the lacquers may be removed. So to overcome that, once again we lacquer it, then it is cured and it is passed into the flanger, and the edges are bent, and here the seaming is done and the lids, they are fixed on these flanges. Again, the stiffness is enhanced by beading, and then it is palletized, and this is to see how much force it can tolerate when it is transported and stacked. Now let's look into this demonstration. This is a two-piece container. So here if you see, there's no seam on the edges. So the end is part of the body itself. This is called body, and this is the flanger. Bend over here on the edges you will find, or over which the lid is placed. And this is a two-piece container because after seaming, you just pull it off and the lid comes out. So this is a two-piece can, whereas in the three-piece can, you will have a separate bottom. The bottom will also be separate, and then it is also seamed here, and then the contents are filled. And inside this, the lacquers are given. It's a coating on the surface, which we'll be discussing in the coming session. Lacquer, it protects the contents from interacting with the container or the metals. If it reacts with the metal, it may contaminate the product, or it may interact with the components of the content. So to prevent that, we apply lacquer. Just imagine that this is a metal sheet, and if you whirl it, just make it in a cylinder form. So this will be the cylinder. So first step in the can making is to form the cylinder. So it is a cylinder formed like this, and this both edges, they are welded together. It is we don't add adhesive or apply any material over here, because this can, it comes in direct contact with the food, and nothing should leach into the product. So therefore, it is welding or soldering is done. So it is just crimping here. It's like stapling the thing. And then the sheet is passed into the flanging machine, where the flanges are developed. So it is just a bending on the edges where the lids will come and fit. So this is how the can is developed in three-piece. So now let's see the steps. There are 12 steps in a three-piece can development. First, the strips are cut from a large coil. These are large strips, and they are lacquered on the internal side, and then they are dried or cured, and then these are cut into small pieces according to the length of the can body, and they are converted to cylinders, and the edges are welded using electric current. And where the welding has been done, we are again spraying the lacquer. This is again cured, and then it enters into the flanger, where it is flanged at the bottom and top, where the lids come and fit. And then for the three-piece can, the bottom lid will be the plain end. It is seamed to the body, and it passes through the beader, because beader, it gives the strength to the seam where the second piece has been attached. And then it is tested for pinholes, fractures, dents, and also whether it can withstand pressure during stacking. So this is how the three-piece can is developed. There are three-piece can and two-piece can. Three-piece can, they can be developed using these 12 steps. And two-piece can we'll be discussing in the coming session. So let's wind up for today. Thank you.